Hi folks. In today's lesson we're going to be discussing something called continuity and what it means. So let's take a look at the formal definition of continuity. It says that the function f is continuous at a given value, x equals c, if the limit exists. Okay, now earlier in the curriculum we learned that the limit exists if the left-hand limit and the right-hand limits are equal. Now, given this camera and how small the font is, you can barely see this minus sign and this plus sign. Okay, but this one means from the left and from the right. Okay, now the limit, so that's one aspect that we need to check, and then the next thing that we need to check is the limit has to equal the function value at x equals c. Okay, so let's take a look at a few graphical examples. So notice that there is a break at the line x equals 1, or at the value x equals 1. Okay, that makes the limit from the left and the limit from the right not equal to each other. The limit from the left is 1, but the limit from the right is 3. Okay? So therefore the limit does not exist. And if the limit does not exist, then that means that it failed to be continuous based on this first bullet point here. The limit has to exist. Okay? So we're going to frown about that one. So if the limit doesn't exist, there's no way for it to be continuous. In example 5, we get a little bit happier because when we take the limit from the left and the limit from the right, we get the same value, 5. So that kind of makes us smile about part A, which says the limit exists. Okay? So the limit exists. And maybe we'll write a smiley face after that. The limit exists. Smile about that. All right, so however, remember there's a second thing that we need to check. We need to check to make sure that the function value is equal to the limit value. Well, the limit value is 5, but the function value is 2. F of 2 is not equal to the limit value as x approaches 2. Okay? So this function f of x is not continuous. Okay? So there you have it. Let's take a look at a third example. Maybe we'll get lucky and find something that is continuous today, right? So here we go. Here the limit of the function exists. All right, let's double check that. So from the left-hand side of 1, I'm getting 1, and then from the right-hand side of 1, I'm getting 1. Okay, so that's good. The limit exists. Okay? And now let's look at the function value. The function value at 1 equals the limit value as x approaches 1. So we're pretty happy about that because there's a solid dot right there. Solid dot. Okay, and it doesn't have to actually be represented as a dot. It could have just been a corner, just as long as it's not an open hole, okay? So we are super happy about that one. We'll give this one 2 smiley faces because the limit exists and the function value equals the limit value. All right, so that's continuity in a nutshell. I encourage you to look at the next page for a few more examples. So this next page seems to be a lengthy page, so I'm going to include that in the next video.